Okay, so it was requested that I would walk you through the free response from this Chapter 22 Part 2 assignment, which seems like a good idea given that I'm not sure that most of us were on target with understanding where we were at. So I have the question pulled up on the left side of the screen, and I'm going to do my work over on the right side, so hopefully you can follow along. So this is the question about the milk containers. And in Part A here, you needed to work all the way through a test of significance. So you should have started Part A by stating your hypotheses. So your null hypothesis would have been that the mean was equal to 128, and your alternative hypothesis would be that the mean was less than 128. I did have a couple questions about what about the issue of it being greater than, and based on the wording of the problem, it tells you that basically the containers have to contain at least 128. So if the containers were containing a bit more than that, they would not be out of compliance. But they are out of compliance if the containers are not holding as much as the label claims that they are. So that's really what we are concerned about there. So there are your hypotheses. Now, you would be needing to look at your conditions. So talking through those here, I'm not going to necessarily write out everything here in the wording because I'm afraid that I'm going to run out of space, but you do have randomness because it tells you in the wording of the problem that they've randomly selected 12 containers. So that is right here, a random sample of 12 containers. So you do know that. We're going with the assumption that they have had this machine fill at least 120 containers with milk. That seems very reasonable given that we don't have any reason to believe this is a new machine. And then even though your sample is only 12, which we know is too small, you are told that variability in the filling process causes the actual contents of the milk containers to be normally distributed. So that is essentially telling you that the population, meaning all bottles filled by this machine, is normally distributed. So you are fine on your conditions there. So that means that would allow you to conduct a one sample t-test. That is a place that some of us were lacking, is we did not state for the grader that you are doing a t-test. And that's a one sample t-test for a population mean is what you would be conducting there. Now, most of you did state your t statistic, which was given on your calculator. That t value is approximately negative 1.32. And most of you also correctly stated your degrees of freedom, which in this case would be 11. Remember, your degrees of freedom are always one less than your sample size. So 12 minus 1 would give you that 11. You could use your calculator here to do the work for you to then create for you your p-value that you need. So the test on your calculator should have given you a p-value of approximately 0.11. So then we need to actually draw our conclusion. And a few of you are lacking in the conclusion, so I think this is an important part to be aware of as well. So your alpha value here would be 0.05. Remember that you need to be stating that for the grader. So at alpha equals 0.05, with your p-value being 0.11, which is bigger, you would fail to reject your null hypothesis. So if you're failing to reject the null, that means we are leaving in play the idea that the mean is 128 ounces. So what we would be saying then is the company, we have evidence to indicate that the company is in compliance with what they are stating on their labels. So again, I'm not writing out all the wording for you. I'm just kind of talking you through. Please look at your individual comments, because if your wording was off base, I gave you very specific ways that you could improve that wording. For the most part, we were okay. Some of us just did not go all the way to saying, what does it mean when we're failing to reject? Well, failing to reject in the context of this problem means that you're keeping the null, saying that that company is in fact in compliance. And that's just a stealing of the words that were given here in the problem. All right, so as we move on to part B, so on part B, it says that we're looking for a probability. So what is the probability that a randomly selected container filled by this machine contains at least 125 fluid ounces? So on part B, a lot of you stated that you were using normal CDF, which is correct. Some of you didn't even bother to state that. So if you didn't, I really do need to see that. The grader needs to see that to know where did this come from. But to strengthen that response, I think you should really be starting off by telling the grader, why can you use that? So you can use that because you know that the population is normally distributed. Okay, so you know that from above. So that's really what's opening the door for you to be able to use normal CDF. And when you're using normal CDF and you're wanting to know the probability that a randomly selected container filled by this machine contains at least 125 fluid ounces. Okay, so that would mean 125 or greater. So your low end on your normal CDF would be 125. Your upper end you can put as anything high. So I mean, if you want to put that as 200, you can put it as 200 just to make sure that you capture all of the curve. And then you need to put in your mean, which this is given up here in the wording. It tells you that you have a mean of 127.2 and a standard deviation of 2.1. So those are the other two things that you would be plugging in. And that should have given you approximately 0.9332. So there's about a 93% probability that if you just pick one bottle, it has at least 125 fluid ounces in it. So then moving on to part C, a lot of you saw what was going on here as well. So it says an inspector will randomly select 12 containers filled by this machine and record the amount of milk in each. What is the probability that the minimum recorded in the 12 containers will be at least 125 fluid ounces? So then it gives you a note that says each of the 12 containers must contain at least 125 fluid ounces. So this is really an and probability. So it's saying that what we want is we want to grab a bottle and we want it to have at least 125. And then we want to grab another one and we want it to have at least 125. So it's 125 and 125 and 125 over and over again. So if you remember from semester 1, when you have an and probability, we multiply those together. So this is really telling us that we're going to take that value from part B, that 0.9332, and multiply it by itself 12 times. So once for every single bottle. We know that when we're multiplying something by itself, that we're really just raising to that power, right? Something times itself is squared. So if we do that 12 times, it's to the 12th power. And this would give you approximately 0.4362. So there's about a 44% probability that you could do this and get all 12 bottles to have at least 125 ounces in them. So that's what that tells us. All right, moving on then to part D. So you can see on your screen now that this table is coming up that you were given for part D. And I know it's kind of hard to see. But on this table, most of you got this part right. I'm just not fully convinced from sort of the output that I saw that you really knew why you were getting what you were getting. So On Part D, it says, looking at the sorted list of 150 minimums. So they were nice enough to give you a sorted list. It's not like you had to search through all of this. And that tends to be true when they're giving you a large table on the exam. I think that definitely with the 45-minute time limit on this year's adjusted exam, that if you got anything of this nature, it would be sorted. So you have this sorted list going on here. And we are looking for values that are at least 125. So if I'm looking for at least 125, then I'm looking at here, moving on, right? So that is 66 values. So we are really saying that 66 of the 150 values that were gathered in this simulation were at 125 or more. And if you work that out, that becomes 0.44. So in the wording, it says, use the simulation results to estimate the probability that was requested in Part C. So that same probability from a simulation, how many times do we expect that to be 125 or more? And then compare this estimate with the theoretical value you calculated. That theoretical value that they're talking about is that value that you got in the above, 0.4362. Now, the weakness that I saw in your wordings is that some of you did not really state what you were comparing. So for the grader, you could actually show the math. So the part that we got here from the simulation was 0.44 minus 0.4362 that we had from above produces a difference of 0.0038. So you could literally show them the difference and say the difference between those values is very, very small. Thus, what you're really saying is that the simulation is giving a very good approximation to what you found to be the theoretical value. So that's what you really should have shown for a full response there. I didn't really dock anybody for that. I just felt like you didn't know how to show. And so that's really your simple math way to show what's going on. So I hope this helps. If you have questions further on this one, please feel free to let me know. But again, please read your specific comments on AP Classroom because I really try to give you feedback yourself on what you are writing, how you're using your words, and how I would improve it for the grader.